Let's talk about decomposition. So decomposition is obviously the opposite of composition. When we compose functions, we put two things together. When we decompose functions, we take one function and break it apart into two pieces. So, a couple of things before we take a look at the examples. Some helpful hints that you should be looking for. The first thing we want to look for is parentheses. So for example, if I have something like x squared plus 3 to the fourth power, or I have something like x plus 7 cubed, that'll be easy to break apart an inside and an outside piece. The second thing I want to look for is a radical. So for example, the square root of 2x plus 5, or the cube root of x plus 3. Once again, that will be easy to break into two pieces. I want to look for a fraction. So something like 1 over 2x plus 3, or x over 5 plus x cubed. Something that has a top and a bottom will be easy once again to break into two separate pieces. And then the last thing you want to look for is something that's kind of already in two separate pieces. So 1 over x plus 7. Here's my first piece, and there's my second piece. This will make a little bit more sense once we go through the examples, but just some helpful things to look out for as we go through them. So we have 4 examples here. It says, for each function h below, find two functions f of x and g of x such that h of x equals f of g of x. Now, remember, with compositions, order was important. So once again, with decompositions, order is going to be important. If you take a look at the directions, the g of x is going to be our inside function. So, let's take a look at my first example on the top left. H of x equals 3x plus 7 squared. So here's one of our helpful hints or things to look out for. I have a set of parentheses. So I'm going to make this inside piece, whatever's inside the parentheses, my inside function. So I'm going to make g of x equal to 3x plus 7. So now what's left over is really just a parentheses squared. So I'm going to make that my f of x. But remember, it's a function, so I have to have a letter to evaluate, or a variable. So instead of parentheses squared, I'm going to put x squared. So there are my two pieces. G of x, my inside function, is 3x plus 7, and f of x is x squared. Now remember, the nice thing is that you can check these because you can do the composition. F of g of x. So I want f of 3x plus 7. So f of x is x squared. This matches, so I did it correctly. There is my answer. Let's take a look at the one on the right. H of x equals 1 over 2x minus 3. Here's another one of our helpful hints. I'm looking for a fraction. So I'm going to make my denominator my inside function. So g of x is going to be equal to 2x minus 3. So what's left over? 1 over a parentheses. So that's going to be my outside function. But remember, I can't have a parentheses, so I'm going to make it 1 over x. So there's my decomposition for h of x. Let's take a look at 2 more examples. H of x equals the cube root of x squared minus 8. So once again, here's one of my helpful hints. I'm going to make the inside piece my inside function. G of x is equal to x squared minus 8. What's left over? The cube root of a parentheses. So that's my outside function. F of x is equal to the cube root of x. And then let's take a look at h of x on the right over here. I have x plus 1 squared plus 2 times x plus 1. If you notice, my parentheses are the same. So because my parentheses are the same, that's a helpful hint. My parentheses is going to be my inside function. So what's left over? Something squared, or parentheses squared, plus 2 times parentheses. So my outside function, f of x, is going to be x squared plus 2x. Wherever my g of x was, I was left with the parentheses. And then remember, it's a function, so my parentheses has to be a variable. So here is my decomposition.